Okay. Mr. Keshav, can you hear me now? I can't see your question in the chat box. So if you have any question, please type your question in the chat box so that we can discuss. I need to see the chat box, ma'am. Yes. Still it is not audible. Okay, fine. So if you have any questions, you can write it in the chat box, and the question should be from the internal combustion engine part. Yeah, how does the volumetric efficiency affect the engine efficiency? Yes, because overall efficiency is also dependent on the volumetric efficiency. So you have to understand that if there is any leakage, so combustion is not only the process wherein fuel is sufficient. So to have the efficient combustion, you also need to have sufficient amount of air which is present inside the engine inside the combustion chamber. So if there is any leakage of air which is sucked into the combustion, then the efficiency will deteriorate. So that is how the combustion total efficiency of the engine depends on the volumetric efficiency. So volumetric efficiency is very important, considering the fact that to have the efficient combustion, we need to supply sufficient amount of air into the engine chamber, in the combustion chamber. But if there is any leakage, and if that air which is supposed to be there in the combustion chamber is not there during combustion process, efficiency will reduce. Okay, I have a few questions. How do we represent intake, process and TS diagram? Okay, so let me discuss this question first. That this question is asked by Mr. Keshav. So you know that okay, so let me tell you intake combustion, because ideally during intake process when cylinder when piston is coming from top dead center to the bottom dead center, then inside the combustion chamber pressure should be less than the atmospheric pressure. It is assumed that this process is there at a constant pressure, and you can represent by constant pressure line. But if you have observed the valve timing diagram, you have seen that that particular process is slightly less, the pressure is less than the atmospheric pressure. So if you draw a constant pressure line in a PV diagram, you will find that the intake process, that process line is down the constant pressure line, that is atmospheric pressure. Because again let me tell you, ideally when intake pressure is the intake process is there, so in this intake process air is drawn into this engine cylinder, and it is assumed that the pressure inside the cylinder should be less than the atmospheric pressure. But you also can represent this process by constant pressure process. Okay, now even if if it is the TS diagram, so basically TS diagram, that if you can draw the process in PV diagram, then you can find out how we can represent the same process in the TS plane if you know the air standard relationship. So if you know the ideal gas relationship, which is used to represent all the processes which are there in a in the internal combustion engine, to represent all this intake, combustion, compression, expansion process, then you can do it. What is the significance of studying the standard air standard cycle when it is not possible practically? Yes, very important question. This question is asked by, I do not know the name of the student or learner, make thermal GB. Okay, so let me tell you, that air standard cycles are used to represent the processes, the real processes. Though you are correct, in reality it is very difficult to represent all the processes by the processes which is modeled by the air standard cycle. But the question is, I have discussed in one of the classes of this particular module, representing processes using ideal gas release equation. It is though not exactly the real process, but the deviation is also minuscule. So it is not a bad approximation to represent a real process by a process using air standard cycle, wherein ideal gas equation is used to mathematically represent the process. Okay. In the normal combustion curve, the curve without combustion is called monitoring curve or motoring curve. So this is basically motoring curve, because you know that normal process basically you are using. So basically what you are doing, you are trying to have the piston movement using an electric motor. So basically you are trying to represent the compression and expansion process just by taking the piston up and down within these two centers, that is BDC and TDC, using an electric motor. Okay. Next question is Mr. Shivam Kumar. What is working of IC engine? What is working of IC engine? This question is not complete. So I'm not comfortable to give answer to this question. Learners or students who have registered for this course, internal combustion engine and gas turbine, and those who are attending this live session, I request you all to ask any question from the internal combustion engine part, and for that you can type your question in the chat box so that we can start discussing them. Mr. Shivam Kumar, your question is not complete. Why diesel engine makes more noise comparatively to petrol engine? See, it is a very intuitive question. You understand that diesel engine, it also you can understand from the octane number, cetane number, those two numbers I have defined. So what does the cetane number represent? That is very important to understand this question. Second thing, you know that diesel engines are having relatively higher compression ratio. So the rise of pressure at the end of the compression stroke is also very high, and the volume of the total charge or combustion product is also very high. Considering that fact, it is the sound is more noisy. Okay, Mr. Kesav is asking one question. If we draw a constant pressure line on TS diagram to represent intake process, say for auto cycle, will the area under it represent the heat addition? See, I really do not know, because intake process, is there any heat addition? No, because intake process is simply to suck air from the ambience into the engine cylinder. Ideally, there is no heat interaction. So it is of no use to know what is the intake process, what is the heat addition. So there is no heat addition in the intake process. Only air is drawn into the combustion chamber by bringing the piston from the top dead center to the bottom dead center, and the process is assumed that it is not a heat interacting process. So registered students who are there in this live session shall request to post your questions, if you have any, in the chat box so that we can start discussing them. Area under a process line on TS diagram, it represents the heat addition. So that is why I told you, can you draw the process line, a constant pressure line in the TS plane? So if you draw it, you will find what is the heat addition. Why we can't use hydrogen as a fuel? Okay, so there are many questions. Let me ask one question that is asked by Mr. Parth. So again, thank you very much for your question, because hydrogen can be used as an alternative fuel, but only important issue with hydrogen is it needs, if we use hydrogen as a fuel, we need to have higher storage tank. So placing a bigger tank in the engine cylinder is also I can say, and it is also an issue, and it is because of this particular issue, use of hydrogen as a fuel in internal combustion engine is nowadays even restricted. Next question is Mr. Sarad. If D change, then enters D engine cylinder. I really do not know. So if diesel, I didn't get your question. If no charge left to combust during the compression stroke, that what will happen? I didn't get your question. It would be nice. I request you to again clarify your questions a little bit more so that I can interact. Mr. Dasari, your question is explain about fuel rating in CI engine. See, I am not supposed to discuss about the fuel rating about CI engine here. For that, you can consult with any standard book, you will find it. So when you are talking about fuel rating, it also depends on the characteristics of a fuel, which is very important. If I can recall correctly, I have discussed about the fuel characteristics, and if you know it carefully, then you can understand how can you rate a fuel, whether it is used in SI engine or CI engine. Why SI engine take long ignition delay? Okay, let me ask again one by one. See, ignition delay is basically, I have discussed again, let me tell you, ignition delay has two components. One is called chemical delay, another one is the physical delay. So these two delays, that is chemical delay, that is purely due to chemical composition of the fuel and also the state of the charge before the combustion, together with the physical delay. You know that we are supplying fuel into the engine cylinder. We are also using spark plug to ignite the charge in case of a SI engine. So all these are mechanical devices. When these devices are on use for a long time, their functionality, they are not properly functioning. So basically, we also need to assume that there should be physical delay. So the moment we are trying to switch on the spark plug, the time duration from switching on the spark plug to create a spark, and that too when the spark is created, depending on the composition and also state of the charge that is there in the combustion chamber, this total delay is the ignition delay. For the SI engine, one most important part is the spark plug ignition time, and it's required to ignite the total charge that is there in the combustion chamber. So that is why it is more. Then next question is how to work two inlet and two exhaust valves in a single cylinder diesel engine. So two inlet and two exhaust valves, it is again an important question, but first of all you need to know why you need to have two inlet and two exhaust. Instead, why don't someone use multi-cylinder engines? So if it is needed to have two intake and two exhaust, then that is only the design aspect. So someone who is involved with the design of internal combustion engine cylinder, this question is properly addressable by them. Okay, is it possible to have zero cutoff ratio in diesel engine? How it is possible to have zero cutoff ratio in a diesel engine? It is not possible. Okay, if charge entering the cylinder during suction stroke gets ignited due to hot spot in such a way that there is no charge left to combust during the compression stroke, then what will happen? Will it knock? See, Mr. Sarad, you are asking again an interesting question. I would suggest that probably there is one common question, that if you use petrol in a diesel engine, what will happen? So now question is, because there will be a few hot spots definitely. So when you are introducing charge, that is air fuel mixture, which is known as air fuel mixture or charge pertaining to the SI engine. Now it is because of these hot spots, some charge will definitely start igniting, and so we have discussed that secondary flames will be produced, but it is very unlikely that there will be multiple hot spots which at a time will try to ignite the charge which is there in the combustion chamber. Second thing is, you know that engine cylinder, I have discussed this issue again, that our main objective is to have high efficiency of the engine, but still we need to reduce the temperature of the engine cylinder by a coolant. So when coolant is there, so probability of having so many hot spot in the engine cylinder is very less. So though if the situation is there, if we consider a hypothetical situation that there are many hot spots in the because of the somehow hypothetically if we consider that number of hot spot is more, then perhaps all the charge, when the charge is in contact with those hot spot, secondary flame will produce. So before coming to the primary flame front, the secondary flame front will proceed and they might collide each other, and definitely there will be a chance to have a knock. Okay, so is the twin spark system improve the combustion of charge in the cylinder? See, again I am telling you, because twin spark, as I was discussing about the possibility of having the secondary flames. So if we try to have twin spark, perhaps we can arrest the possibility of having those secondary flames, and that too probably we can enhance that quickly total charge will be combusted. So perhaps it can be expedited. So the entire combustion process can be expedited. Okay. There was a question in assignment which asked that when cut-off ratio tends to 0, efficiency of diesel cycle will be equal to auto cycle. So sir, is it not an invalid question? See, I would like to have, I will look at this question again, but cut-off ratio tends to 0, it is again not physical pertaining to this compression ignition engine, but I will definitely have a look at it. Again, next question is asked by Mr. Sarad, if we advance this spark too much, then apart from resistance, the motion of piston, does it not cause detonation due to unbound charge reaching or exceeding the self-ignition temperature? See, ideally, your question is, if we advance this spark, then that before reaching piston, before reaching at TDC, perhaps there will be huge resistance that is there. And your second question is detonation due to unbound charge reaching or exceeding the self-ignition temperature. Detonation, because if we try to advance this spark, the motion will not be very smooth, that it will be having some kind of, because the piston has to move towards TDC against a resistance. But when the piston is reaching at TDC, say all the unbound charge will again be in a position to combust, then there will be effective pressure, and that pressure will create a thrust on the piston face and piston will come down. So I don't find anything, and that will cause detonation. How turbulence in the combustion chamber affect the main flame? So Mr. Dipankar Verma, thank you very much for your nice question, because I have discussed this issue. In fact, in the last live session, by mistake, I was I had given answer to one question, and that question was asked about the spark advancing and retardation. But the question is turbulence, because the turbulent flow are characterized the formation of eddies and vortices. So if the vortices and eddies are there, because of their inherent structure, small vortices will try to take the flame towards inner side, so that you can what we can do, we can control the flame speed. So if we can control the flame speed, that is very important, considering the detonation and knocking. So this part I have discussed. I suggest you to go through go to that particular lecture, wherein you will find the factors which affect the flame speed. Okay, having a higher octane number for an SI engine fuel means that it is high self-ignition temperature, and having higher Satan number for a CI engine fuel means that it is low ignition temperature and lesser delay period time. I didn't get your question, but I suggest you, because the Satan number and octane number and the delay period, these are very trivial issues, and those are nicely written in any standard textbook you will find. So you can consult with any standard textbook, either written by William W. Pulkravik or by V. Ganesan. You will find answer to this question. Students and learners who are attending this live session, shall request you all to post your question in the chat box, so that we can discuss if that question is from the internal combustion engine part. Area under intake stroke on PV diagram represent positive work. Area under intake stroke on PV diagram positive work. So sir, why do we say this is ideal stroke? Yes. So positive work, ideal stroke we are telling, but let me tell you. Again, Mr. Kesav, I would like to clarify this question. I can give you an example. Suppose if you have excess money, then you are going to bank to deposit that money, and when you need, you can go to bank and you can withdraw money. The similar concept can be applied even here. So when a piston is having movement between these two positions, like that is bottom dead center and the top dead center, so piston will be having reciprocating movement, to and fro movement, and when piston is coming from top dead center to the bottom dead center during intake stroke, we are borrowing energy from the flywheel. So though it is basically work, because again I suggest you to go to the basic of thermodynamics, whether you can, that is a sign convention. So maybe that work is there, but that work is not obtainable from the cylinder, because that work is given to the system, right? So to bring the piston from TDC to VDC, we are borrowing energy from the flywheel. So definitely that is the work done, but there is a change in volume, but that work is not obtainable from the engine. So that is why it is called ideal stroke. That stroke is of no use, because if you consider there are 4 strokes, out of these 4 strokes only the power stroke is the stroke from where we are getting power. For to have remaining other 3 strokes, we need to take power from the flywheel, and that is why these are called ideal stroke. So learners, if you have any question, kindly post your question in the chat box. Someone asked me about one question that was that is related to assignment. I assure you that I will definitely have a look at it and I will get you back. You can write me an email. I will get you back with the answer of that particular question. Learners who are attending this live session, I shall request you all to post your question in the chat box so that we can discuss. Mr. Sarad, again I would suggest you, because if you would like to really learn the internal combustion engine, you may consult one good book. Already I have given you the name of the author, William W. Pulkravik, or even V. Ganesan. You will get answer to this question. This is very trivial and you can understand better by reading that particular book. Someone asked me about my email ID, so you can text my name in Google. You will find it from IIT Guwahati website. And does exam have problem to solve with Casio? I didn't get your question. Okay, so I mean, you meant to say, do you need calculator or not? In the exam, I don't think that there will be numerical problems which you have to solve. I mean, bigger problem. So maybe a small numerical problem you have to solve. Now, it is up to you whether you will be able to solve that problem with your in pen and paper, or you need to take help from of calculator. That is up to you. Learners, if you have any question, kindly post your question in the chat box. Mr. Dipankar, because I can see that you had asked me an interesting question, that how turbulence in the combustion chamber not affect the flame. I mean, I have discussed this particular issue in detail in that class, so I suggest you to go through that particular lecture. You will find answer to this question. But I can tell you that turbulent flow is characterized by the formation of vortices, and when there is a vortex or there are vortices in the flow field, even in the combustion chamber, those vortices, because of their inherent motion, will try to disturb the main flame. Now, the way they are affecting the main flame is very important, considering that undesirable phenomenon, that is detonation and knocking. So I have discussed this part in the lecture. I request you to go through that lecture. Learners who are attending this session, shall request you all to post your questions if you have any in the chat box. Okay, so which air standard cycle is used to represent two-stroke SI engine instead of a four-stroke SI engine? Is it Otto cycle only? See, because there are many cycles, air standard cycles, which are used to represent the Otto cycle. Now, whether it is two-stroke, I mean, you have to first identify what are the two different strokes. So, knowing what are the two different strokes, you can represent those processes in the using the air standard cycle. So, Mr. Keshav, I again suggest you that first of all you need to identify what are the two different strokes instead of four strokes which are used to represent the processes of a two-stroke engine. So, identifying these two strokes, you can understand how you can represent all these two processes in the PV or TS plane, and which air standard cycle can be used. Shall request learners who are attending this session to post your question in the chat box so that we can discuss them now. Shall request you all not to ask the trivial questions, because I mean you need to go through lectures, and also you need to consult with books, textbooks, and if you go through and if you read textbooks carefully, you will find you will understand several things even in a better way or carefully. how to represent two simultaneous process on PV diagram. So that is what I am telling. You have to understand what are the two different processes. Then how can you represent all the processes? So why not to try on your own? So why can't you try on your own to represent all the processes in PV plane? If you try, then you will understand in a better way. If you are unable to represent all the processes, or if you are unable to understand how you can have only two stroke engine, then only I will try to help you. So you try on your own first. If you have any issue, then please do write me. I will try to help you. I can give you a hint. I can give you hints. First of all, you need to identify what are the two different strokes for the two-stroke engine. Identifying these two strokes, then you can think of mapping all the processes in the PV plane. So this is what I can tell you now for the time being. Students who are here in this session, shall request you all to write your question in the chat box so that we can discuss them. Which fuel creates more pressure inside of cylinder, petrol, diesel, to push down the piston? Mister, I really do not know, because this question is very it has no basis. The question has no basis. You know that diesel engine and petrol engines, these two engines are having different compression ratios. Now the rise in pressure at the end of the compression stroke is definitely not same for both these engines. So which fuel will create more pressure, and that is very difficult to say from your question. Now if you ask me a question that maybe if it is the SI engine, then pertinent to that engine, which fuel is the best one for to get to achieve maximum efficiency. Okay, so does knocking take place in starting of combustion in CI engine? Starting of combustion in CI engine, knocking is it can, because someone asked me a question that say at the end of the combustion, it all depends on the scenario of the air fuel mixture at the beginning of the combustion, or if it is the SI engine, that is the charge. So now you are asking at the starting of the CI engine, starting of combustion of CI engine. So in the CI engine, what is done? We are introducing air into the cylinder, and that air is compressed. At the end of the compression stroke, fuel is spread into the combustion chamber, and that fuel, because of the high pressure and temperature of the air itself, the fuel self ignite. There is no need of having spark plug. Now question is, and we have discussed about there are different stages of combustion. First phase of combustion and the second phase of combustion. So now this part again, if I recall correctly, I have discussed. So you have to understand, when the first fuel droplet is sprayed or is coming into the combustion chamber, considering this thermodynamic state of the air which is compressed at the end of the compression stroke, that part made that particular fuel will be combusted. It is because of that combustion, pressure will increase, and that pressure creates some amount of disturbances inside this cylinder, in combustion chamber. So before going to have the second phase of combustion, the first phase of combustion can create a trouble for the movement of the piston towards the TDC. So it also can create knock. Learners, if you have any question, Shall request you all to post your question in the chat box so that we can discuss. Okay, Mr. Parth, you have asked me what is delay period. Delay period, let me tell you, I am coming to the question asked by Mr. Kesav, but let me give answer to the question which is asked by Mr. Parth. What is delay period? Delay period is the period, see, when you are, supplying or spraying fuel into the combustion chamber for the combustion. So, starting from the fuel injection, the time required to have the complete combustion, that is the delay period. Let me tell you once again. Suppose at the end of the combustion, at the end of the compression stroke, scenario is that air which is drawn into the combustion chamber during intake stroke will be compressed. When air is compressed, its pressure and temperature will increase. That particular state of the air will allow fuel to self-ignite when fuel is sprayed into the combustion chamber. Now, starting from the fuel injection by a fuel injector to the time which is needed for the complete combustion of the fuel that is sprayed is the delay period. It depends on the chemical delay as well as physical delay. Okay, now coming to the question which is asked by Mr. Kesav, assuming no fuel losses, we know that for engine running at same speed, two-stroke SI engine theoretically produces double the power output as the four-stroke engine. But which engine consumes more fuel? See, no fuel losses. If it is no fuel loss, assuming, how can you assume no fuel loss? Because that is where my question is. You are repeatedly asking me question from the same paradigm, but you are not I think you didn't understand exactly what are the two different strokes of a two-stroke engine. See, in a two-stroke engine, you really cannot trivially neglect the fuel loss, and it is because of this reason four-stroke engines are there in the real application. So long as two strokes are there, you cannot trivially ignore the fuel loss, and that is why the big drawback of the two-stroke engine is the fuel loss. So the question that you have asked has no basis. It is purely an invalid question. Students, if you have any question, you post your question in a chat box so that we can ask. In a two-stroke engine, significant amount of fuel is lost, and that is how two-stroke engines are obsolete today. These are not used. Which type of nozzle used in SI engine? I have discussed there are many types of nozzle. Pintle nozzle, we have discussed about different types of fuel nozzle, and also we have discussed about the merits and demerits associated, of each type of nozzle. So, shall request you kindly to go to the lecture where I have discussed about the types of fuel nozzle and the advantage and disadvantage of using any particular type of fuel nozzle in the context of CI engine combustion. Does evaporated fuel is the reason for a period of rapid combustion? Of course. See, nowadays we are using BS6, it is FI system. Does it have carburetor and FI and CI? Can explain me, sir. I do not know your name, but sorry, because I am not getting your question properly. I request you to write me or email me your question so that I can get you back with the answer. Okay. Let me ask one question that was asked by Mr. Parth. That does evaporated fuel is the reason for period of rapid combustion? That is let me tell you, that when the fuel is spread into the combustion chamber, the first drop of fuel, when it comes into the combustion chamber, it evaporates quickly, and higher that fuel take part in the first phase of combustion. So higher the evaporation, higher will be the combustion. That is true. Okay, now Mr. Dashari, you asked which position of a fuel injector is placed in cylinder to get maximum efficiency. Mr. Dasari, I didn't discuss this particular aspect, the positioning of the fuel injector, and that was not included in the course which was taught by me. Mr. Raja, you have asked me a question, what is the difference between knocking and detonation? Very interesting question, but let me tell you, if you have understood the detonation and knocking, because knocking, first of all, you have to understand, then you will be understanding what is detonation. It has no relation whether knocking is for the CI engine or detonation is for SI engine. So, knocking is, what you need to understand first is knocking, then if knocking start from every points, then the total or gross event you also have to understand. So one is the localized event, another is the gross event. I have given you hint, you try to get answer to this question from any textbook. Let me tell you, knocking and detonation, these two are interrelated. So basically you have to understand, one is the localized phenomenon, other is the global phenomenon. So you have to understand which one is the localized and which one is the global. Mr. Parth again, how does the position of the engine affect engine efficiency, and why does some bikes have engine placed horizontally? Engine efficiency, so basically this is the placing, vertical and horizontal. So one issue may be that I am trying to give answer because it has as you are telling positioning of the engine. One answer could be because that is to place, concerning the bike as you are talking about, just placing the engine, that is only the engine configuration arrangement. And if we talk about the engine efficiency, then perhaps if you place in a horizontal engine, you know that chances of removing all the combustion products from the engine cylinder will be more easier. And if we can remove the combustion product from the engine cylinder at the end of the power stroke, that is during exhaust stroke, then we can reduce the possibility of having mixing of fresh air, fresh charge with the combustion product from the previous stroke. If we can reduce the possibility of having this particular aspect, we can increase the efficiency. Student, if you have any question, if you post the question in the chat box so that we can discuss them now, and we are having only another 5-6 minutes for this session. Learners who are attending this session, shall request you all to post your question in the chat box so that we can start discussing them. We are having only 5 to 6 minutes time to complete for this session. Mr. Keza, okay, fine. Though I was talking about your two-stroke engine, so but let me tell you, that would be a hypothetical case. So if you can assume that there is no fuel loss, your question was which engine consume more fuel? See, there is no question about consuming more fuel, because BSFC, that is brake specific fuel consumptions, that you have to fix. But the question is definitely two-stroke engine, you are having only two different stroke per one revolution, but in the 4-stroke engine you are having your question was okay, 4-stroke double power output of a 4-stroke SI engine. Definitely, because in a 4-stroke engine you have only one power stroke vis-a-vis 3 idle stroke. So in a 4-stroke engine you are having only one power stroke versus 3 idle strokes. On the other hand, in a 2-stroke engine we have only one power stroke versus one idle stroke. So definitely the output of the 2-stroke engine will be more, but at the same time you also need to keep in mind that in a 4-stroke engine, since there are 3 idle strokes, engine is getting relatively more time to reduce its temperature. So considering, so not only the power output is only the matter of concern, but also you need to think about the engine lifetime. So considering that fact, 4-stroke engines are preferred over the 2-stroke engine. But this brake specific fuel consumption, that is very important. So that 4-stroke engine, since you are having only one power stroke, and so we have to supply the fuel in such a way that the power output will be such so that we can have power to execute remaining 3 idle strokes by taking power from the flywheel. Students, learners who have registered for this course and those who are attending this session, sir, request you all to post your question in the chat box. We are having only 2-3 minutes for this session. Most welcome, Mr. Parth. I suggest you to read a good textbook to have more understanding on different aspects that we have, I have discussed. Okay, can we say 2-stroke engine consumes double the fuel than 4-stroke engine since we supply fuel for each revolution? No. So basically, supply of fuel, because you are telling that per cycle, so that is the question, because there are 2 revolution per cycle. So it is designed in such a way, because you have to understand that in a 4-stroke engine there is the piston is moving up and down. So to complete one cycle there are 2 revolution of the piston, while for the 2-stroke engine in one cycle there are 2 revolutions. So basically you need to understand you are supplying fuel only during the combustion process, combustion stroke. So let me tell you that in case of a 4-stroke engine we are having only one power stroke, so we are supplying fuel 1, and for that amount of power that we are getting we are trying to execute 3 idle strokes. But in case of a 2-stroke engine the cycle is remaining same, so this is one cycle, there are only one revolution. So basically we are supplying fuel for that particular combustions to take place the combustion, and using that power we are executing only one stroke. So supply, and what you are telling, that is in a way true, because let me tell you, that is why I have been telling you that you please understand what are the 2 different strokes. The fuel consumption, let me tell you, because why 2-stroke engines are obsolete nowadays. First of all, you really cannot ignore the fuel loss through the exhaust during exhaust process, and the 2-stroke engines are also consuming little more fuel. So that is why these 2-stroke engines are obsolete nowadays. So why the fuel consumption in a 2-stroke engine is little more than the 4-stroke engine, you have to understand first. In addition to the fuel loss, significant amount of fuel is lost in a 2-stroke engine. On the top of that, little more amount of fuel you need to supply to the 2-stroke engine. Why that amount is needed, you have to understand first. So, Mr. Kesab, thank you very much. No, that is not an issue because you have asked me all the questions pertinent to one, but shall request you to discuss or to consult one standard textbook. And as I told you that you can take one book which is written by William W. Pulkrajek to get better understanding of several aspects that I have discussed in this course. So, learners and students who attended this particular session, I sincerely thank you all, and I have tried my best to give answer to your question. Had I not, discussed any particular question, I shall request you all to write me email so that I can get you back. Last question, that is, can you use fuel injection system with petrol engine? That is very important question. I do not know your name because I can't see. Yes, because now nowadays carburetor is obsolete almost. So nowadays there is no engine which is carbureted. So fuel injection is there. So thank you very much. So with this I stopped my session here today, and I thank you all for your questions. Wish you all the best. Thank you.